Interfaces can be executed in two different modes. The less common is the one first listed, that's interactive mode. That typically is not used because it's going to open up its own little command window, and if you were to exit out just to log off the machine, then that process would fail. See, typically we will start this in a non-interactive mode when we basically launch this as a Windows service, and that's of course what we recommend. So what do we have the interactive version for? Well, the interactive version is really a good way of debugging the interface. Sometimes you'll find things that will appear in the command window that we may not have thought to write into the message log. It's unlikely, but sometimes you'll find that. And for other testing purposes, for example, checking the accuracy or the checking whether this has been installed properly as a service or not, sometimes we suggest you start it interactively first. And then after you start it that way and check out everything works, then you can go ahead and run it as a service. Now, interestingly enough, both of them use exactly the same batch file, because in the case of an interactive execution of the interface, we simply execute the batch file, and that's where we pass the arguments. In the case of starting up as a service, well, the executable itself, the service itself, is going to look for the batch file and parse out the parameters in there and use that as it executes. So here's how the interface works. I think the best way to kind of understand something is pretend you're the interface. Let's look at what the interface does. The first thing the interface needs to do is it needs to establish a connection to the host Pi server. Remember, the interface in most cases is not running on the Pi server. So it's external to the server. It establishes a connection. First thing it does when it establishes that connection, and probably gains entry using a trust, it's going to retrieve a point list from the Pi server. Now, this is a very special point list. It's only going to retrieve those Pi tags whose point source is associated with that interface, and I'll explain how we make that association later. So it's going to receive basically a subset of the points. It will then validate the point configuration that it receives from the Pi server with the data source. So in other words, if the point database says that on this particular Bailey data source, you know, there's a location in this particular memory address that we need to read, then we're going to validate that with the data source. We'll check that memory location, and if there's any kind of a problem, we're going to write a message into the pipc.log. Now, that's something we omitted so far, but let me discuss that briefly. The absolute best place for troubleshooting an interface is to go into a directory under Program Files pipc. It's in the dat directory, and the name of the file is pipc.log. So let me sort these by name. As you can see, we generate multiple copies of it. The most recent one is the one called pipc.log. That's where we store all the messages that are sent by the interfaces. As you can see, here's the OPC interface sending messages. In this case, error messages. But that's the best first place to look for any kind of message problems or any kind of startup problems. So as we validate, we write messages to the message log. Once everything validates, we will go ahead and start doing data collection. Okay? And by starting data collection, we basically mean we're going to start scanning the data source and retrieving the data into Pi. Now, if there is any kind of a change in the Pi server that will affect the interface, then every 2 minutes that interface is going to check to see if there is such a change. And when we do find that change, we're going to go ahead and propagate that change out to the interface. So that's why changes to the tags collected by an interface, they can take up to 2 minutes for those changes to be recognized. Now, technically, you may notice that if there are massive changes, then after the 2-minute cycle, if we detect these changes, we will process 25 changes at a time and then wait 30 seconds and process the next 25. So if you're doing 3,000 edits, that can take quite a bit of time to go through the system, 25 at a time. So sometimes it's actually faster to stop and restart the interface. Of course, at that point, you may lose data if you're collecting data in real time at that point.